Okay, our last page, example 4 and 5. So example 4 says, determine the coordinates of the points on y equals x squared plus 1 that are closest to point 0, 2. So the graph has been given to you of x squared plus 1, and I graphed on my, put on my picture the point 0, 2, and then I just put a random point on the parabola and called it xy. So I just made one that looks like it's maybe going to be the closest. So is that the only point that's potentially going to have that exact distance, 2.02? Hopefully you're saying no. Hopefully you're thinking, oh right, the other side, it's symmetric, it's reflectional. So this point over here would also be the same distance to that, so negative xy. So determine the coordinates. You know, sometimes we parenthesize that letter so we don't give away the fact that there would be two answers, but you need to go back and look at stuff like that and say, oh, wait a minute, there has to be two answers here. So we have x comma y. Now, if we're trying to find the closest distance, well, I've said that word a few times, you need to think distance formula. What is the distance formula? Well, that's the square root. It's just the Pythagorean theorem over again. It's x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared, because essentially, remember, you're making a right triangle right here. Right, so we have x2 minus x1, which is this horizontal distance, and we have y2 minus y1, which is that vertical distance. We square them, take the square root to find the length of the hypotenuse. Well, we can't have x's and y's, so we need to use some kind of information to change everything to terms of x. Well, ding, 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 we have that right here in our equation. If this is point x, how do we get point y? Well, we would take the value of x, square it, and add 1, and that would be our y value. We can now plug this in to our equation. So the distance of this blue segment right here, which I now drew green, is the horizontal distance, which is going to be x minus 0 squared, because remember, we're trying to go to 0, the point 0, 2. Plus our y value over here to the right is going to be x squared plus 1 minus our y value over at 0, 2 is 2. So we're going to square that. So now you can leave it like this, and you can plug it into your calculator just like this, or you can simplify it, it's up to you. But go ahead and pause now and plug this into your calculator and see what you get. See if your graph looks like mine. Okay, so you should have gotten your final answer to be 0.707, 1.5, and negative 0.707, 1.5. Because remember, once you get your x value, that's representing the x distance on this coordinate system, and you're plugging it in here, the y equals x squared plus 1 to get your y value. It asks for the coordinates, so here are your two coordinates. All right, awesome, we're doing our last one. Exercise 5. To be honest, I think I would try exercise 5 completely on your own. It's another fairly straightforward one with the volume and area, so I would go ahead and pause, try to set it up, and then you can kind of look back and I'll write all the solution out and then explain it with the solution already there. So go ahead and pause and try it on your own. All right, so here I've completed the question. It says a rectangular package sent by a shipping company can only be sent if the sum of the perimeter and its base and length is less than 120 inches. So I should have put less than 120 inches, but I didn't, sorry. So the perimeter has to be less than 120 inches. And what do we have? It says perimeter of its base and length. So the base and then the length. So I did 4x plus y. I solved for y. Why am I doing that? Well, then I have to show that the volume of the package is this statement right here. So we're asking you to show it. So if you make the base your square, which is x squared, so then it's x squared times the height, and the height in this case is y. So x squared times y, but I'm not going to plug in y. Instead, I'm going to plug in 120 minus 4x. Then I distribute, and I would end up in the end with negative 4x cubed plus 120x squared. The next question says, what is the practical domain? Right? So for the practical domain, well, that's going to be associated with your zeros up here. If you were to sketch the graph, which I did down here for letter C, your graph, then you have, you can see that my practical domain is going to be this portion here. I have a 0 at 0, a double root at 0, and I have a single root at 30, right? So these are my zeros. 0 is a double root. It's a negative coefficient, so it's going to come down, bounce away, and then come back down. So in between 0 and 30 is going to be my practical domain, because otherwise I'm going to have negative x values. You can't have that. You can't have negative dimensions in your box. Or you're going to have a negative volume, which obviously you also cannot happen, so you have to have a practical domain from 0 to 30. Part C says determine the dimensions of the package that yields a maximum value. Maximum, you can see this is all going together. Here's my maximum value. This part of the graph does have a maximum value. You find the maximum, it was at 20. What are the dimensions? So it's 20 by 20 because I have my box right here, and then my height. I plug in that value of 20 and I get a 40. So it's 20 inches by 20 inches by 40 inches. Then finally, letter D says, find the values of x such that the volume would equal 13,500. Well, you need to put in your y sub 2, 13,500, so it comes up with this line right here that goes through it. You find the intersection points. You have an intersection at 15. You have an intersection at 24.271. Are those the only intersections? No, you have one more intersection over here, which is a negative x value. So it says which of these values is a physical impossibility. So that would be this negative one over here. And therefore, I'm not going to list it. Or you would explain, actually, that the negative 9.271 is the physical impossibility because you cannot have negative dimensions. So that's it. Some of the word problems will definitely be difficult. I think some of the problems on the quizzes and tests will definitely be challenging. So make sure you're understanding the setup because the setup is key. Then you plug everything into your calculator. Make sure you know how to get at least 3 decimal places on your calculator when you're working in your graphs. And if you have any questions on that, then you need to talk specifically to your teacher or to one of the Precalc teachers. Hope you had a good time at IASIS and did well, and we'll see you soon.